Hey everyone, welcome back to Curiosity Chronicles. I'm Asan, and today we're embarking on a mind-bending journey through the concept of time travel. From scientific theories to popular culture, let's explore the fascinating possibilities and mysteries of traveling through time. You know, the human fascination with time travel is as boundless as the universe itself. We yearn to witness pivotal moments in history, right the wrongs of the past, or catch a glimpse of what the future holds. But is time travel just a fantastical dream? Or could it be a scientific reality waiting to be unlocked? Today, we'll delve into some of the most intriguing theories and concepts that suggest time travel might be more than just science fiction. Fasten your seatbelts, folks, because things are about to get seriously cosmic. Our journey begins with a giant of modern science, Albert Einstein. Einstein's theory of relativity turned our understanding of time and space on its head. Before Einstein, time was seen as rigid and unchanging, but Einstein showed time is relative. Imagine you're on a spaceship near light speed. Time slows down for you compared to someone on Earth. This is called time dilation. We've observed it with atomic clocks on jets. Clocks on jets tick slower than on Earth. Einstein's general relativity shows gravity warps space-time. This warping affects time, slowing it in stronger gravity. Time passes slower at sea level than on Mount Everest. So, time travel to the future. According to Einstein, it's happening all the time. All you need is a fast spaceship or strong gravity. Now, let's talk wormholes. Imagine folding a piece of paper in half. Now imagine a tiny tunnel connecting the two sides. That, my friends, is a simplified way to think about a wormhole. Wormholes are theoretical tunnels in space-time, potentially connecting distant points. Essentially, they're cosmic shortcuts, maybe even time machines. Think of it like poking a hole through a sheet, creating a shortcut. Some physicists believe wormholes could connect different points in time. Imagine emerging in a different part of the universe or a different era. You could witness the Big Bang or travel to the distant future. The catch: wormholes are still theoretical. We haven't observed one directly, and the technology to manipulate them is far beyond our current capabilities. But hey, as a wise person once said, the only difference between science fiction and science is time. Now, let's say we figure out how to build a time machine. The next question is, what happens when we travel back in time? Do we have free will to change the past, or is history fixed? This is where the Novikov self-consistency principle comes into play. This mind-boggling principle, named after physicist Igor Dmitrievich Novikov, suggests that if time travel is possible, the laws of physics would conspire to prevent any paradoxes. In simpler terms, it means that even if you could travel back in time, you wouldn't be able to change the past in any way that contradicts what's already happened. Your actions would somehow always align with the established timeline. Let's say you went back in time to prevent a tragic accident. According to the Novikov self-consistency principle, you'd either fail to prevent the accident, or your actions would inadvertently lead to the same outcome, perhaps in a different but ultimately inevitable way. Think about it like this. The past is already written. It's just that we're experiencing it in a linear fashion. Time travel wouldn't allow us to rewrite history, but rather it would confirm that our actions, even across time, are part of a single, consistent story. Now, let's dive into one of the most mind-bending interpretations of quantum mechanics, the many worlds interpretation. Brace yourselves, folks, because this one's a real doozy. Imagine this. Every time a quantum event occurs, every possible outcome of that event doesn't just disappear into the ether. It actually branches off, creating a new universe. In other words, there isn't just one reality, but a potentially infinite number of parallel universes, each representing a different outcome of every quantum event that's ever happened. So what does this have to do with time travel? Well, some physicists believe that traveling back in time wouldn't actually change our past, but rather it would create a new timeline, a separate branch in the multiverse. Imagine going back in time and making a different decision than your past self. In this scenario, you wouldn't be changing your original timeline. You'd be creating a new one, branching off into a parallel universe where that alternate decision played out. This means that there could be countless versions of you out there living out different lives in different realities. It's a mind-boggling concept, but then again, the universe has a knack for being mind-boggling. Let's talk about time loops, a popular trope in science fiction that's as fascinating as it is potentially terrifying. Imagine being stuck in a repeating cycle of events, reliving the same day, hour, or even minute over and over again. Think of the movie Groundhog Day, or the time loop episode of Star Trek: The Next Generation. In these stories, characters find themselves trapped in a temporal anomaly, forced to repeat the same events until they learn a lesson, break the cycle, or right a wrong. Time loops raise intriguing questions about free will, destiny, and the nature of time itself. If you were stuck in a time loop, would your actions even matter, knowing that the loop would reset and your choices would be undone? Some physicists have theorized about the possibility of closed time-like curves, which are essentially paths through space-time that loop back on themselves, theoretically allowing for time travel to the past. If such curves exist, they could potentially create time loops, trapping unsuspecting travelers in a repeating cycle of events. Whether time loops are a real possibility or just a product of our imaginations, they continue to captivate our minds and fuel our fascination with the mysteries of time. Thanks for joining me on this thrilling exploration of time travel theories. From Einstein's groundbreaking relativity to the mind-bending possibilities of wormholes and the multiverse, we've covered some seriously cosmic territory today. While time travel remains a tantalizing mystery, the very act of exploring these concepts expands our understanding of the universe and our place within it. Who knows what scientific breakthroughs await us in the future? Perhaps one day time travel will be as commonplace as hopping on a plane. If you enjoyed this journey through the mysteries of time, don't forget to hit that like button, subscribe, and click the bell icon so you never miss an episode of Curiosity Chronicles. And let me know in the comments below which time travel theory intrigued you the most. See you next time.